All right, the last part of this is the zeros of a quadratic that we need to go over. So exercise 1, let's look at the quadratic y equals x squared minus 2x minus 3. So the zeros is where it actually crosses the x-axis. And we have this on the graph already. So it's right here and right here. So the zeros are actually at -1, 0, and 3, 0. Verify that the positive 0 is correct by showing that y equals 0. So what we're going to do is we're going to plug y equals 0 into this equation up above. So we have 0 equals, and the positive is 3, so 3 squared minus 2 times 3 minus 3. So 3 squared is 9, minus 6 minus 3. 9 minus 6 is 3, 3 minus 3 is 0, so it's true. We're going to factor this expression. So if I were to factor this, remember that it is what multiplies equal -3 and adds to equal -2. Well, -3 and +1. So how do these factors compare to the zeros? So we're looking at the zeros up above. My zeros were +3 and -1. So it looks like it's the opposite of what is being added or subtracted from x inside the parentheses. So based on that, let's check this algebraically. So if y equals 0, and I'm going to do this one, so what multiplies equal -10 adds to equal +3. Multiplies to equal -10 adds to equal +3. That's a +5, -2. So what we really have here is we have that x plus 5 equals 0 and x minus 2 also equals 0. So I have x plus 5 equals 0 and I have x minus 2 equals 0. So we're going to solve for x on each one. Subtract 5, x equals -5, add 2, and x equals 2. So the zeros of this equation are x equals -5 and +2. I put those in a solution set. So the zero product law says that if two or more quantities have a product of 0, then at least one of them must be equal to 0 in the symbolic form. If a times b equals 0, then either a is 0 or b is 0 or both are 0. So we're going to do the same thing that we just did for the last one. I have x plus 7 equals 0, and I also have x minus 2 equals 0, and we need to solve each one for x. Go ahead and pause here if you'd like to see if you can figure these out on your own. So x is -7, and x is 2. So my solution set is -7, +2. Next one, 2x minus 1 equals 0, and 3x plus 4 equals 0. If you look at letter A, what we just did, we could have done what we noticed before is that it would be the opposite. So it's -7, +2. But on letter B, I have numbers in front of the x, which make it a little bit harder to solve. So now I have 2x equals 1. Then we divide by 2, so x is 1/2. Subtract 4. 3x equals -4. Divide by 3. And x equals -4/3. So our solution set is -4/3, +1/2. You may have also noticed that I put them in numerical order. So these can be factored. So we're going to find the roots or the solutions to each of the following equations by using the zero product law. So multiplies to equal -12 adds to equal 4. Well, that's going to be +6 and -2. These ones are easy. We just do the opposite, so -6, +2. The next one, we're going to need to factor this one first. So my greatest common factor is 2x, and I'm left with x minus 7. So this is a little bit harder to see right away, but it's 2x equals 0 and x minus 7 equals 0. So we know that x minus 7 is going to be 7, because what minus 7 equals 0? Well, what times 2 equals 0? 0. Looking at letter C, these are ones you should recognize. The x is a perfect square, the 25 is a perfect square, and we have a subtraction in between, which means it's going to be x plus 5 times x minus 5 equals 0. So it will be negative 5 and 5. And the last one, these are the more difficult ones. So 2 times negative 12 is negative 24. So multiplies to equal negative 24 and adds to equal 5. Well, I know it's going to be 8 and negative 3. So I have 2x on each one. So my first one is going to be 2x minus 3. My second one, this becomes x over 4, so x plus 4 equals 0. Some of you can look at this right away and you can mentally solve for 2x minus 3 equals 0. And you would automatically see that for this one, you would add 3 to both sides, then 2x equals 3, then you would divide by 2. So x is 3 over 2. And then this one, what plus 4 equals 0? Negative 4. Find the zeros of the quadratic function algebraically, and then verify your answer by using your calculator to sketch a graph of the parabola using the window indicated on the axis. So first of all, I have a greatest common factor in each of those, and it's 3. So I'm left with x squared minus 2x minus 8. So what multiplies to equal negative 8 adds to equal negative 2? Well, that's a negative 4 and a positive 2. You will notice that we have a 3 on the outside. That 3 actually gets ignored when we're talking about the roots or the zeros. My zeros are still going to be negative 2 and positive 4, because positive 4 minus 4 equals 0 and negative 2 plus 2 equals 0. The 3 just tells us that it's going to be a skinnier graph. So my zeros are still going to be at negative 2 and positive 4. My y-intercept is still going to be at negative 24. Now you need to be using Desmos to decide what it would look like using those parameters. So 1, negative 27 is where it crosses, or the minimum. So it's going to look like this-ish.